Hello friends, welcome again. The first topic we will cover is Introduction to Statistics. Let's begin. What is statistics? It is the methodology for collecting, analyzing, interpreting and drawing conclusions from information. In simple words, we can say that statistics consists of mathematical methods which are used to summarize, analyze and interpret a group of numbers or observation. Practically, a statistical method has been applied in every field of science and management to solve various problems. For example, in agriculture, is new seed or fertilizer is more productive? In medical science, what is the right amount of dosage of drugs to treatment? In politics, how accurate are the opinion polls? And in economics, what will be unemployment rate next year? Technical problem, how to improve the quality of product? Insurance company, what should be premium to be paid by customer? Let's go to our next topic, branch of statistics. Basically, there are two major types of statistics, descriptive statistics and inferential statistics. Descriptive statistics is all about organizing, summarizing and making sense of data. In inferential statistics, we use sample data to make an inference about a population of data. The methods which are used in descriptive statistics are: the first one is construction of graphs, charts and table. The second one is calculation of center tendency like mean, median and mode, and dispersion and like range, variance, standard deviation. The methods which are used in inferential statistics are calculation of point estimation and interval estimation, and the second method is hypothesis testing. Both of these methods are based on probability theory. Now we will understand the process of doing the data analysis. First, we will collect the data and prepare it by structuring and removing any errors. Then we will summarize the data using graphs, tables and calculate the descriptive measures like mean, median, standard deviation, range. These two steps, when combined, it is called descriptive statistics. If we go one step further, then we will do the analysis of data like exploring relationship between variables and compare groups. Now after combining these three steps, it is called inferential statistics. So now we can say that descriptive statistics and inferential statistics are interrelated. Like when we take sample data from population, first we organize and summarize it with descriptive statistics before going for the inferential statistics methods. Now this finishes our first lecture and I hope you have enjoyed it a lot. Thank you and happy learning. Hello friends, welcome again. The topic which we will cover in this lecture is population and sample. Population and sample are two basic concepts of statistics. So population can be defined as collection of all individuals or items under consideration for study. Similarly, sample can be defined as part of the population from which information is collected. Now we have understood the concept of population and sample, so we also need to understand how to describe or explain the features of population as well as sample. So for this, parameters, or we can say population parameters, are used to explain or describe the features of population, and it is defined as a non-numerical summary of population. And the example of parameter is population mean and population standard deviation. Similarly, for sample, statistics or sample statistics are used to explain the features of sample, and it is defined as a non-numerical summary of samples which is used to understand or make inference about parameters. and its example is sample mean and sample standard deviation. Now let's understand this concept of population and sample with diagram. First, we will take collection of individuals under consideration for study, that is what we call population, and it is defined by its parameter, that is population mean and population standard deviation, which is unknown. Since doing the study on whole population is going to be very costly and time consuming, therefore we will draw a sample from the population to study it. And then we will calculate the sample statistic, that is sample mean and sample standard deviation. Now based on this calculation, we will make inference about the population parameters. Now this ends the lecture on population and sample. I hope you have enjoyed it a lot. Thank you and happy learning. Hello friends, welcome again. The topic which we will cover in this lecture is measurement. Now let's understand the concept of variable and its type. What is variable? A characteristic that varies from one person or thing to another. That is, a variable is any characteristic that varies from one individual member of the population to another. The example of variables for humans are height, gender, weight and eye color. The variable can be classified into two parts, quantitative variable and qualitative variable. The quantitative variable is defined as variable which yield numerical information or measurement. Its example is height and weight. Qualitative variable is defined as variable which yields non-numerical information or measurement. Its example is eye color and gender. Now quantitative variable can be classified into two parts, discrete and continuous variable. Discrete variable is defined as sample space containing a finite or countable infinite number of values. In simple words, we can say the variable is discrete if it has only countable number of distinct possible values. For example, the number of children in family, it can be 3, not 3.53, or the number of students taking this statistics course. Now continuous variable is defined as a sample space contains interval or continuous span of real number. Or we can say in simple words, a continuous variable can take any value within the range of the scale. For example, the time to respond to a question is a continuous variable since scale is continuous and not made up of discrete steps. Say the response time could be 1.5 seconds. The other examples of the continuous variable is height, weight, temperature, etc. This finishes our lecture on measurement, which is the first part. I hope you have enjoyed this lecture a lot. Thank you and happy learning. Hello friends, welcome again. The next topic which we will discuss is scales. Besides variable being classified as qualitative or quantitative, it can be described according to the scale on which they are defined. Scales give certain structure to the variable and also defines the meaning of variables. It can be classified into two parts, quantitative variable and qualitative variable. Quantitative variables, whether discrete or continuous, are defined either on interval scale or on a ratio scale. Now let's take a look at interval scales. Interval scales represents a quantity and has equal units, but for which 0 represents a simply additional point of measurement. For example, Celsius temperature scale. Celsius temperature scale can be negative, positive or 0 degrees Celsius. Also, the temperature scale is divided equally, or we can say an equal interval. Now let's understand ratio scale. Ratio scale represents quantity and has equality of points or units. Also, this scale also has an absolute zero. That means no number exists below 0. For example, amount of money. 0 indicates absence of money. So practically money can't be negative. Other example is height and weight. So both of this height and weight can't be 0 or negative. Now let's go to the qualitative variable scale. The qualitative variable scale can be defined either by nominal scale or ordinal scale. Nominal scale. In this, the number that simply used as identifiers or names represents a nominal scale of measurement such as male, female. In simple words, we can say that nominal scale is categorical on names which are unordered. For example, gender or religion. Now let's understand ordinal scale. It represents an order series or relationship or rank order. For example, military rank and consumer satisfaction rating on a scale from 1 to 5. This finishes our lecture on measurements. I hope you have enjoyed it. Thank you and happy learning. Hello friends, welcome again. Now let's summarize what we have learned till now. The first topic which we have covered is statistics and its branches. Earlier explained, statistics is all about organizing, summarizing and interpreting the data, then making the decision based on that. It has two branches. First one is descriptive statistics, which is all about organizing, summarizing data and then making sense of data. The second one is inferential statistics, in which we use sample data to make conclusion about the population. The second topic which we have covered is population and sample. So the population is entire set of possible observation in which we are interested, and it is described by the population parameters. The second one is sample, where sample is subset of population from which information is actually collected, and it is described by the sample statistics. The next topic which we have covered is measurement. In this I have explained the variables, which is characteristics that varies from person to person of things. The variable is classified into two parts. First one is quantitative variable and second one is qualitative variable. The quantitative variable yields numerical information or measurement, example height and weight, and qualitative variable yields non-numerical information or measurement, for example gender and eye color. Now quantitative variable can be divided into two parts. The first one is discrete variable, which can be counted or take only certain values, example number of children in family or the number of students taking this statistics course. The second one is continuous variable, which can take value within the range of the scale, for example height, weight. The third important topic which we have covered is the scale. Scale provides the structure and meaning to the variable, and scale can be classified into two parts. The first one is quantitative variables, which include interval scale and ratio scale. Interval scale, in this scale we have equal intervals, with 0 being just another measurement addition, for example temperature scale and degree centigrade, which can be positive or negative and even 0, and its scale is equally divided. The next topic is ratio scale. Ratio scale has also have equal units but with absolute 0 point, which means the value can't go below 0, for example height and weight. Now qualitative variables also include nominal scale and ordinal scale. Nominal scale are categorical or names in unordered fashion, for example religion, and ordinal scales are rank order, for example military rank. Now this ends our summary of the topic which we have covered till now. I hope you have enjoyed this session a lot. Thank you and happy learning. Hello friends, welcome again. The topic we will cover in coming lecture is descriptive statistics. So without delay, let's start. Before we start the lecture, let me just refresh you about descriptive statistics. As earlier explained, descriptive statistics is collection of all the methods for organizing and summarizing the data to make sense of it. And the methods are: the first one is construction of graphs, charts and tables. Second one is calculation of center tendency, which includes mean, median, mode, and dispersion, which includes range variance. Now let's start with our first topic in descriptive statistics, that is central tendency. So what is central tendency? It is a statistical measure to locate a single score that is most representative of all scores in a distribution. In simple words, we can say that descriptive measure that indicate the center of all the observation. That's why it is also called center of measure. There are three ways of finding the center of measurements. First one is mean. It is most commonly used measure of center. The mean is calculated by taking the sum of all observed value in a data divided by number of observations. Let's solve the example. I will solve this question in an Excel sheet. Now here we will first calculate the sum of all observation, which can be done by the sum function in Excel. Now selecting all the observation and enter, clicking enter. Now the number of observation in given data can be calculated using the count function. Now selecting all the observation and clicking enter. Now we can get the mean by dividing the sum of observation with the number of observation. So the answer is 4.667. In short, we can say 4.67. Now let's move back to our PPT. So here in the PPT I have solved this question manually. You can see an answer is also coming 4.67. Now let's move to our next important measurement, that is median. What is median? It is a middle value of distribution data listed in numeric order. Why we use median instead of mean? Because mean fails to reflect most of the data, and we use median instead of the mean to remove the influence of outliers. And how we calculate the position of mean? And it is calculated by using simple formula, that is n plus 1 divided by 2, where n represents number of observation here. Let's take the example. The given data set is the odd number sample size. First we will place the data in numeric order or ascending order, and using the median position formula, that is n plus 1 divided by 2, here the n is 7, position is coming out to be 4. So 4, where 4 lies? 1, 2, 3, 4. So the 5 is the value at the position 4. Now let's take another example of even number sample size. First place the data in ascending order, and using the median formula of position, that is 6 plus 1 divided by 2, and it is coming out to 3.5. Now 3.5 lies between position 3 and 4. As you can see, 1, 2, 3 and 3.5, 4 and 5. Now take the average of the value at position 3 and 4, and that will give you the answer 4.5. Now I will solve this question in Excel sheet. First we will find the median for a data set whose sample size is odd, and here it is calculated using simple median function. Here the median function, that is coming median, then selecting all the observation, closing bracket and tapping enter, and it is coming out to be 5. Now similarly we will calculate median for the even number sample size. So median here, same, then selecting all the observation, it is coming to 4.5. Now you can see that one advantage of this calculation in Excel sheet is that we do not need to arrange this data in ascending order. Let's go back to the PPT. The third important measurement which we use in calculating center tendency is mode. The value that occurs most frequently, it is called mode. Let's see the example. In a given data set, 2 is occurring 1 time, 3 is occurring 3 times, 4 is occurring 4 times, and 7 is occurring 2 times, and 8 is occurring 3 times. As you can see, the 4 is most occurring number in the given data set. So the mode of this data set is 4. Let's solve this question also in Excel sheet. We can solve this question using the mod function here, and selecting all the observations and closing the bracket and clicking enter. So the answer is also same here, 4. Let's go back to the PPT. I think we have covered all the topics which comes under center tendency. I hope you have enjoyed it a lot. Thank you and happy learning. Hello friends, welcome again. The topic which we will cover in this session is dispersion. What is dispersion? It is the statistical measure of the spread of data points in a distribution. In simple words, we can say that it measures the extent of variation around the center. We can measure dispersion in 2 ways. First one is range. So what is range? Range is the difference of maximum value in data set and minimum value in data set. In using range, a great deal of information is ignored since it only considers largest and smallest value and disregarding other values. So instead of using range, we can use interquartile range. To understand interquartile range, first we need to understand percentile, decile and quartile. Percentile. Just like median is the middle value of distribution and divides the data set into 2 equal parts, that is bottom 50% and top 50%. Similarly, percentile of the variable divides the observed value into 100 equal parts. Let's understand the percentile in detail. Roughly speaking, the first percentile P1 divides the bottom 1% of the observed value from the top 99%. The second percentile divides the bottom 2% of the observed value from the top 98%, and so forth. Let's see how we can find the value at given percentile. The value at given percentile is R equal to I divided by 100 into n plus 1, where R is position of observed value, I is percentile, n is number of observation. If R is not integer, then let IR and FR be integer and fractional part of R. The observed value can be calculated using interpolation concept. So the value of ith percentile is S1 plus FR into S2 minus S1. Here S2 is value correspond to IR and S1 is value correspond to IR plus 1. Now let's solve one problem to understand this percentile concept more clearly. First, arrange the number in ascending order. After arranging the number in ascending order, let's find out the R value, that is position. Here I is 25, n is 10, so the value coming out is 2.75. The 2.75 is not an integer which is in between the value of 5 and 7. So using the interpolation concept, here 5 is S1, 7 is S2, IR is 2 and FR is 0.75. So the observed value after calculation is 6.5. So let's go back to dispersion PPT. Now let's understand decile. Just like percentile, decile is a variable which divides the observed value into 10 equal parts. Similarly, quartile is a variable which divides the observed value into 4 equal parts. Let n be observed value increasing order. The first quartile is at position n plus 1 divided by 4. The second quartile Q2, which is median, is at position n plus 1 divided by 2. The third quartile Q3 is at position 3 into n plus 1 divided by 4. Now interquartile range is the difference of value at Q3 and Q1, and it includes 50% of the data. So the maximum value, the minimum value and the quartiles, when put together, they provide information on the center and variation of the variable in a compact way. When written in increasing order, then it is called 5 number summary. Now we finishes part dispersion, and the second part will be discussed in next session. I hope you have enjoyed the session, and thank you and happy learning. Hello friends, welcome again. In this lecture we will cover second part of dispersion, that is variance. So let's start. What is variance? Variance measures the average square distance that scores deviate from their mean, and the formula for calculating variance is summation of xi minus h bar raised to the power 2 divided by n, where n is number of observation. If we take the square root of variance, then we will get standard deviation, and it is most commonly used measure of variation. Now let's understand standard deviation with simple example. We can solve this question in two ways. First one is manually and the second one is Excel sheet. Let's first do it manually to understand this concept more clearly, and we will follow following steps to solve it. The first one is find the mean of the data set and put it in the table format. Then find the difference of each observation with the mean. Then square each of the differences. Once you have the square of each differences, then do the summation of the squares, which is coming out to be 55.42. Then divide the summation by the number of observation, and the variance coming out to be 7.91. Now take the square root of variance, and that is the standard deviation of the data set. We will solve this question in Excel now. So this is a data set. We will use the simple standard deviation formula to solve it. That is standard deviation dot p stand for the population. Selecting all the observation, closing the bracket and enter. And the answer is coming out to 2.81, which is same answer as we got it manually. And let's go back to main slide. Now let's see some basic points about the standard deviation. The first one is when individual scores are closer to the mean, then the standard deviation is smaller. The second one is where individual scores are spread out far from the mean, the standard deviation is larger. And third point is standard deviation is always positive and typically reported with mean. This finishes our lecture on dispersion, and I hope you have enjoyed it a lot. Thank you and happy learning. Hello friends, welcome again. In this session we will solve a question related to the dispersion. Given a data of 102 people age, and we need to find first one is mean, second one is median, third one is mode, fourth one is range, fifth one is 5-point summary, sixth one is value at 85 percentile, and seventh one is variance and standard deviation. We will solve this question by using the Excel. So let's go. So this is the data which was given in the question. Now let's calculate mean. The mean is calculated by using simple average function and taking all the observation values and then enter. That is, the mean is coming out to be 41.25. Now median can be solved as simple median function and taking all the observation, closing bracket and enter, and it is coming out to be 39.5. and mode is by simple mod function and taking all the observation values and enter. Range, you know, is the difference of maximum value and minimum value. Maximum value. Next we take here max function, bracket open, and taking all observation value, bracket close. So maximum value is coming out to be 72. Now minimum value, taking the min function and taking all observation value and enter. So we have got the maximum value and minimum value. Let's take the difference of maximum value and minimum value, and range is coming out to be 53. Now the 5-point summary. We already calculated the maximum value, so it is 72. We also have calculated the minimum value, and it is 90. Now let's calculate quartile. Let's get quartile 1. Quartile EXE, and it says that return the quartile of a data set based on percentile value from 0.1 and exclusive. So that is what we require, exclusive only. And taking that, sorry, and we also need to take the which quartile we are talking about, and it is 1. And what is quartile 2? Quartile, taking all the observations, and quartile 2 you can see that the quartile 2 and the median value is same, as the median is the second quartile. And the third quartile 3, and now we have got the all values. Now value at 85 percentile, and this is calculated by using percentile.exe. Here we need to take exe value, not inclusive, and taking the all the observation, and k represents here what is the percentile here, close, and the value is coming out 56, and the variance I use simple variance formula, and standard deviation. By 2 ways you can do it: by taking the square root of it, of the variance, and it is coming out to be 12.73, or also you can use std standard deviation dot p, and taking all observation, bracket close, and enter. It is coming 12. So both are same. So this is how we got all the answer. Let's go back to the PPT, and this is the answer of the question for your future reference if you want to again come back and solve this question yourself. So this finishes our session. I hope you have enjoyed it a lot. Thank you and happy learning. Hello friends, welcome again. The topic which we will cover here is graph and table for qualitative data. So the qualitative data are presented graphically either as a pie chart or as a bar graph. Let's take an example. In this example, we have been given a blood type of 40%. So let's draw a pie chart and a bar graph. First of all, we will summarize the data in the table format. Here, after counting the blood type, we found the count of O is 16. Similarly, the count of A is 18. The count of B is 4 and AB is 2. After that, we have calculated the percentage of each type just by dividing the count by total observation, which is 40 here. Now let's make a graph using Excel. This is the table which I have explained just now. Now we will draw a bar graph here. Selecting the percentage column, clicking the insert button and selecting the bar chart, horizontal one, and this is the chart we have got. Now let's format this bar graph. First of all, label. If you click the chart, design and format will appear at the top most. Go to the top left corner and then click the add chart element. In this, just click the bottom labels, and according whatever is suitable for you, just select that option. For me, the outside end is much better view. I am selected, and the chart title can be, let it, bar graph. And now we also need to correct this major axis. For that, right click the bar graph and select the select data option and just click edit here. Select the blood type column, click OK here, OK here, and it is done here. So this is a bar graph which I have made. Now let's make the pie chart. Again selecting the percentage column, going to insert, then clicking the pie chart, and this one I have selected. We have got a pie chart, and then again clicking the pie chart and a design will appear. Then again going to add chart element, so go to the data labels. I prefer the outside end, and this we have got it. Let's change the title, let it be pie chart. We need to change the legend here as well. Right click the pie chart, select here and edit the, and select the blood type and OK. So it has been changed. So this is how we have made the bar chart and pie chart. So let's go back to the main slide. This is a bar graph which we have made in Excel. This is a pie chart. After doing all the calculation, let's understand some important terminology. What is frequency? It is a number of observations that falls into particular class or category of the qualitative variable. Here in this question, count is actually frequency, and also we can say that frequency of a O type blood is 16 and 16 is frequency and O type is the class. Relative frequency, it is just a percentage calculated by dividing frequency of a class by total observation. Now this ends our session on graphs and table for qualitative data, and I hope you have enjoyed it. Thank you and happy learning. Hello friends, welcome again. The topic which we will cover in this session is graph and table for quantitative data. Quantitative data are usually presented graphically either by histogram or bar graph. Let's take example. In the given question, we have age of 102 people. Now we have to draw a histogram using Excel. Before that, we will summarize the data in table format. First of all, I have created class interval having a range of 4 years, like 18 to 22, 23 to 27, and so on. I want to highlight that you can choose your own range. It's up to you. It can be 5 years or 6 years. Now count the number of observations in the data that belongs to each class interval, that is frequency, which is shown in second column. Then we have calculated percentage by dividing frequency by total observation. Now let's go to the Excel sheet to make histogram. This is the same table which I have explained just now. Now to make histogram, we will select the frequency column like this, and go to the insert button and click the bar chart. So this is the histogram. Now we need to format this graph. First of all, click the bar, the design and the format will show at the top. Now go to the add chart element, click the data labels and select offset end. Now we need to close the gap between the bars. For that, again click the bars, right click it and select format data series. Now you see that there is a gap bit is there. Now to close the gap, just do like this and it is done. Now problem is that we are not able to differentiate the bars. For that, just click the bars and go to the format and just click the shape outline. So now it is clear. Let's change the title as well. This is the graph histogram which we have built. Now let's go back to the main slide. This is the same histogram which we have built in the Excel sheet. This finishes our lecture on graph and tables for quantitative data. I hope you have enjoyed this session and thank you and happy learning. Hello friends, welcome again. In this session, we will summarize what we have learned till now in descriptive statistics. The first topic which we have learned is central tendency and way to measure it. So central tendency is measured to locate single score which represent the distribution. And first way to measure the central tendency is mean, which is calculated by dividing sum of observation by the number of observation. The second one is median, which is middle value of distribution. The third one is mode, which is more frequently occurring observation. Now dispersion. It is the statistical measure of a spread of data points in the distribution, and it can be measured in two ways. First one is range, which is the difference of maximum value and minimum value. Then percentile, which divides the observed value in 100 equal parts. Decile, which divides the observed value in 10 equal parts. Quartile, which divides the observed value in 4 equal parts. Now the other way to measure dispersion is variance, which measures how much is the deviation from the mean, and the standard deviation is the square root of variance. Graph. The qualitative data is best presented by pie chart or bar chart, and quantitative data is best represented by histogram or bar chart. Box plot shows the center and variation of the observed value, and scatter plot shows linear relationship between two variables. So this ends our session on summary of descriptive statistics. I hope you have enjoyed it a lot. Thank you and happy learning. Hello friends, welcome again. In this session, we will cover inferential statistics. So let's begin. Before starting with the topics under inferential statistics, let's understand inferential statistics again. For our study, we have collected data related to our interest area. Since it will be very time consuming and costly to do analysis on collected data, therefore we have drawn sample from given population. Therefore we will do analysis on given data and derive information from sample. So this process of inferring insights from sample data is called inferential statistics. Now let's move to our next topic, random variable. As earlier I have explained that variables are numerical description of the output of an experiment. Let's understand it with example. Here the question states that in a bag there are 8 balls, 4 reds and 4 blue, and randomly withdrawn 4 balls from the bag. So what is the number of red balls in each trial? Let x be a random variable which represents number of red balls. Let's do first trial. In this trial, the first ball which is drawn is blue one, second one is blue, the third one is red, and the last one is blue. So here x is equal to 1 since the number of red ball in first trial is 1 only. Let's do second trial. Now in this trial, the first ball which is drawn is blue, the second one is red, the third one is red, and last one is also red. So here x is 3 since the number of red ball in this trial is 3 only. Let's do the last trial. In this trial, the first ball which is drawn is blue, the second one is blue, the third one is red, and the last one is also red. So here x is 2 since the number of red ball which is drawn is 2 only. So this is how we quantify the random variable. Now again going back to random variables, as earlier explained, random variables can be of two types. The first one is discrete random variable, which assume either a finite number of values or infinite sequence of values, and the second one is continuous random variable, which may assume any numerical value in an interval. Now let's see some of the example of discrete and continuous random variable. The first example of discrete random variable is number of male in a family. The example of continuous random variable is height in centimeters. So this ends our random variable session. I hope you have enjoyed it a lot. Thank you and happy learning. Hello friends, welcome again. The topic which we will cover in this session is probability distribution. How we describe the probability distribution? Probability distribution for random variable describes how probabilities are distributed over all possible values of x. And distribution can be shown in the form of charts, table or equation. Let's take an example to understand it properly. Question states that take a coin and flip it 2 times and count the number of heads. Here x is random variable which is equal to number of heads. Now let's see all possible outcomes. When we flip, the first possibility can be head. When we flipped second time, the possibility can be head again. So here x is equal to 2. Let's now see other possibility. The first can be head, the second can be tail. So here x is equal to 1. The third possibility can be the first coin can be tail and the second coin can be head. Here x is equal to 1 also. The fourth possibility can be both the coins can show tails. So here the x is equal to 2. So let's express all possible value in table format. So in the first row, when x is 0, we had 2 tails and that happened one time only. So there was 4 possible outcomes. So the probability of having 0 head is 1 by 4. That is 25%. Similarly for x is equal to 1, there was 2 occasions when we had head, so probability of having 1 head is 2 by 4, that is 50%. The last one is x is equal to 2. There was only 1 occasion when we had 2 heads, so the probability of having 2 head is 1 by 4, that is 25%. So this is a probability distribution table for random variable, and this distribution can be shown in the form of graph as I have shown in the slides. Now let's solve one more question and express probability distribution in form of graph. Here the question is about past data of TV sales and asking us to develop probability distribution table for TV. Now we will solve this question in Excel sheet. Now the first thing we will do is to calculate the probability of units sold in number of days. So how to do it? First of all, we will do the summation of all the number of days. To do the sum, then selecting all the of the value, then in sum. Now this is the total. Now we will calculate the probability here. So probability is calculated taking 92 divided by 1103 divided by F4 and Control D. Now this is the probability of all the units sold in given number of days. Let's draw our graph. First of all, select all the observed value, then click insert, then go to the bar graph, then select this one So the graph is prepared. Now again click the bars, design and format will appear. Click the design again, then go to add charts element, then data labels and outside end. So our graph is made. Now let's change the chart title. So make it probability distribution. So this is the probability distribution for all the data which was given to us. Now let's go to our main slide. So this is the same table which we have prepared in Excel sheet. So this is the same graph which we have made just now. So this ends our session on probability distribution. I hope you have enjoyed it a lot. Thank you and happy learning. Hello friends, welcome again. Here we will discuss about binomial distribution. Binomial distribution is a common discrete distribution used in statistics. So this distribution can be used to calculate probability of event if it follows following condition. Total number of trials is fixed. Two outcomes are possible, success and failure. Probability of success is same for all trials and trials are independent. The sum of the example is finding the probability of out of next 10 cars having even numbered license. The second one is finding the probability of 9 out of next 20 coin tosses resulting in heads. So what formula for calculating probability in such conditions? So this is the formula for calculating probability. Here n is total number of trial, small p is the probability of success in one trial, small r is number of successes after n trial. NCR is a possible combination for small r in total n. Now let's take example to understand it. Question is, a coin is tossed 10 times. What is the probability of getting exactly 6 heads? Here n is 10, small p is 0.5 because in a trial probability of getting head is 1 by 2, that is 50%, and small r is 6. Putting all values in formula, we will get 0.205. And some of you might have confusion about how to calculate the combination here. So its formula is NCR equal to n factorial divided by r factorial into n minus r factorial. You can also use Excel function to calculate it in Excel sheet, that is bin Excel function, which takes two arguments. Here n represents number of items, r represents number of items being chosen at a time. So this finishes our session on binomial distribution. I hope you have enjoyed it a lot. Thank you and happy learning. Hello friends, welcome again. In this session we will discuss about cumulative probability and probability distribution function. How we calculate the cumulative probability? The probability of random variable x taking value less than small x. Mathematically, the function of x is equal to probability of random variable value less than x. It is just summing up all the probability less than probability of small x. Let's understand it with example. Here the question states that a coin is tossed 10 times. What is the probability of getting less than 6 heads? So given question is based on binomial distribution. Here n is 10, p is 0.5 because when we flip a coin there is two possibility, that is head and tail. Therefore the probability of getting head is 1 by 2, that is 50%, and a small r is 6. So now using the binomial distribution formula, that is probability is equal to NCR into p raised to the power n into 1 minus p raised to the power n minus r. Since this question, it is not asking us to find the probability of getting exactly 6 head in 10 trials, but it is asking probability of getting head less than 6 times in 10 trials. So here we need to sum the probability of getting exactly 0 heads, 1 heads, 2 heads, 3 heads, 4 heads and 5 heads. Now let's solve this question in Excel sheet. So here we will draw a binomial distribution table for the given question. Since here we are talking about getting the probability of getting head less than 6, so we will need to find the probability of exactly of getting no heads, 1 head, 2 heads, 3 heads and 5 heads. So that is the 0 condition, 1, 2, 3, 4 and 5. Here 10 n equal to 10. Now combination of that, which is an Excel function, number is as 10 and number chosen is 0. And p raised to the power, p is 0.5 into raised to the power, r is 0, dragging it down, so 0.5 raised to the power n minus r, n is 10 minus 0, close, raised to the power 0. In binomial distribution, the probability is calculated by the multiplication of NCR into p raised to the power r into 1 minus p raised to the power n minus r into 1 into this one. So this is the probability of all the values. So we need to find the cumulative probability now. Cumulative probability. And doing this, the first row will be same one, the second one will be the summation of the previous one, summation of a previous probability and the current probability, and dragging this one downwards. Okay, this is the probability which we have got. Let's format it with the up to 3 decimal points. Okay, this is the probability distribution table which we have calculated. Now we can also make the graphs. First select the observed value, click insert, go to the bar and click this one. This is the cumulative probability chart which we have made just now. Again going back, now as we have seen, the probability of getting value less than 5 as we have calculated earlier is 0.623, and we have plotted the same table and the graph in the Excel sheet as well. Now let's move to our next topic, is probability distribution function. Now probability distribution function, in short PDF. When we talk about continuous random variable and we want to find probability of getting exact value, so what do you think is the probability? Okay, let's understand it by example. Suppose we want to find the probability of an employee's commute time being exactly equal to 30 minutes, not 30.1 minute nor 29.9 minutes. So what do you think is the answer? The answer is probability will be very low, which is almost equal to 0. But when we say find the probability of an employee commute time being less than 30 minutes or more than 30 minutes, or we can say in a range of 25 minutes to 30 minutes, then we can easily find the probability in a given range or interval. That's why the continuous random variable is expressed in terms of intervals. Now it's clear why we express in terms of interval, but in what form? So it can be done by probability distribution function, in short PDF, or cumulative distribution function, in short CDF. Now let's understand it with the example. Here the question states that rainfall in a day can varies from 0 to 10 centimeter, and find the probability of rainfall less than 6 centimeter. In a given data, we have a rainfall in centimeter and a corresponding probability of happening it. So we will calculate the cumulative probability as I have explained in previous topic. Now we will draw both CDF and PDF probability line chart, and then we will find the probability of rainfall less than 6 centimeter. This is the graph when plotted for CDF and PDF. In PDF, x-axis is rainfall and y-axis is probability. In CDF, x-axis is rainfall and y-axis is cumulative probability. So here the area under the curve in PDF is equal to the cumulative probability in CDF at x is equal to 5. Let's see how. In PDF, when x is equal to 5, the area under the curve is the probability of getting a rainfall less than 6 cm. Let's see how we can do in CDF. At x equal to 5, what is the probability? We can find it in this way. And if you see, the both are giving the same value, that is 0.623. So this finishes our session on CDF and PDF. Thank you, and I hope you enjoyed it a lot, and happy learning. Hello friends, welcome again. In this session we will cover normal distribution. In previous lecture we learned that continuous random variables are best represented by CDF and PDF. Among them, we found that PDF to be more suited for continuous random variable. Now coming back to the normal distribution. It is the most common form of continuous random variable and it has two important points. The first one is it is symmetrically distributed. The second one is its mean, mode and median lie at the center. As you can see, this is a normal distribution with the mean, mode and median lie at the center, and its shape is like a bell curve. The sum of the example of bell curve is height of a group of adult men. Second one is rainfall in a day. Third one is IQs of a group of adult female. Fourth one is weight of a group of a Pepsi bottle. Now let's understand the normal distribution 1, 2, 3 rule. Suppose we have a population with the mean as mu and standard deviation as the sigma. The first rule states that 68% probability of the variable lying within one standard deviation of the mean. It means that there is 68% probability of observed value of a population to lie in a range of mu minus 1 sigma to mu plus 1 sigma, that is this area. And the second rule states that 95% probability of the variable lying within two standard deviation of the mean. It means that there is 95% probability of an observed value of a population to lie in a range of mu minus 2 sigma and mu plus 2 sigma, that is this area. And the third rule states that 99.7% of the probability of the variable lying within 3 standard deviation of the mean. It means that 99.7% probability of observed value of a population lie in a range of mu minus 3 sigma and mu plus 3 sigma, that is this range. Now let's solve a question to understand 1, 2, 3 concept. In this question we have been given a mean of a population, that is 20, and standard deviation is 5. So we need to find probability of a observed value to lie in a range of 10 to 30. So to solve this, we can express 10 and 30 in terms of mean and standard deviation. Now 10 can be expressed as 20 minus 2 into 5, that is mu minus 2 sigma. Similarly 30 can be expressed as 20 plus 2 into 5, that is mu plus 2 sigma. So as per the 1, 2, 3 rule of normal distribution, the probability of observed value lie between mu minus 2 sigma to mu plus 2 sigma is 95%. Now let's solve more question here. Here mean is 20, standard deviation is 5, and we need to find the probability of our observed value to lie in a range of 5 to 35. So here 5 can be expressed as mu minus 3 sigma and 35 can be expressed as mu plus 3 sigma. As per 1, 2, 3 rule, the probability of observed value in a range from mu minus 3 sigma, that is 5, to mu plus 3 sigma, that is 35, is 99.7%. Now let's take another question. Here mean is 20, standard deviation is 5, and we need to find the probability of a variable lying in a range of 10 to 35. First we will express tan in terms of mean and standard deviation. Tan is mu minus 2 sigma and 35 is mu plus 3 sigma. So we need to further divide this range into two more range. First one is mu minus 2 sigma to mu, and which is exactly half of the probability of a variable lying in a range from mu minus 2 sigma to mu plus 2 sigma, and the probability is 95%. So the probability of first range is 95 divided by 2, that is 47.5%. Second one can be in a range between mu, that is 20, to mu plus 3 sigma, that is 35, which is half of the probability of mu minus 3 sigma to mu plus 3 sigma. Therefore the probability of second range is 99.7 divided by 2, that is 49.85%. Combining both, we will get the probability of this question is 97.35%. So this finishes our session on normal distribution. I hope you have enjoyed it a lot. Thank you and happy learning. Hello friends, welcome again. The topic which we will cover in this session is standard normal distribution. In the last topic, we have learned how to calculate the probability of random variable using mean and standard deviation. But if I say that there is no need of knowing the mean and standard deviation, the only thing which we need to know is how far is x, that is random variable, from mean in terms of standard deviation. Now let's understand it with example. In this question, the mean is 20 and standard deviation is 5, and we need to find how far is x from mean in terms of standard deviation. Now let's see how far is x from mean in terms of standard deviation. Here x is 30 and mean is 20, and the difference between 30 minus 20 is 10. When expressed in terms of standard deviation, it is 2 sigma. Here 2 represents the standardized normal variable, that is 2. So generalized formula for finding standardized normal variable is x, that is random variable, minus mean divided by standard deviation. So when we plot a normal distribution graph for G, then the mean is 0 and the standard deviation is 1, and the graph is called standard normal distribution. Now sometimes what happens, there will be a situation where G score is going to be standard like 2 and 3, but instead of it will be 1.4 or minus 0.67. So in that case we need to use the G table. Let's take an example to understand it. So here mean is 20 and standard deviation is 5. So we need to find how far is x, which is 23, and its probability. Using G generalized formula, that is x minus mu divided by standard deviation, and putting values in the formula, we got G equal to 0.6. Also you can see G equal to 0.6 in the standardized normal distribution. Now we need to find the probability using table. So there is two tables, and their use depends on the value of G, whether it is positive or negative. This table is used when G is negative, and this table is used when G is positive. Since G value is 0.6, it is positive, we will use the table in right hand side. So here G is equal to 0.6, so we will search for the row where G is equal to 0.6. Now since there is no number in decimal second place of G, then we will select 0.00 column. If there is some number in decimal second place, for example it is 3, then we will select 0.03 column. Now at the intersection of both row and column, it is a probability of given G. And the final answer for this question is 72.57%. So this finishes our session on standard normal distribution. I hope you have enjoyed it a lot. Thank you and happy learning. Hello friends, welcome again. The topic to be covered in this session is sampling distribution and center limit theorem, in short form CLT. Suppose we are studying the population of data of our interest area, and we need to find its mean and standard deviation. So what is the difficulty in doing so? The difficulty is it is going to be very time consuming and it will cost a lot of money. So to solve this issue, we will draw a sample from population data and find the sample mean and sample standard deviation. So now we need to answer the question that how confident we are the population mean is equal to sample mean. And the correct answer is we can't be 100% correct. And why can't be 100% correct? Because it is due to the sampling error. Is there any other way to determine population mean by using sample mean also with some accuracy? Yes, we can say that population mean is equal to sample mean plus or minus with some margin of error. For this, we will study the sampling distribution. Let's take an example to understand properly. Here the question states that take a sample of 100 employees to find the average time taken to reach the office in a company of 10,000 employees. So estimate the company average time. After analysis, we found that the sample mean is 30 minutes, but we are not confident that company average time is 30 minutes. Company average time is equal to 30 minutes plus or minus margin of error, which can be 2 minutes or 3 minutes. So to determine the margin of error, we need to study the sampling distribution. So this table which is displayed here is the formulas to calculate the population parameters and sample statistics. Now let's move to our next topic, that is sampling distribution and the central limit theorem. Sampling distribution. So what is sampling distribution? It is a distribution of samples of population, and we can say population density function for sample mean of a population. Let's now understand how we can do sampling distribution. This is the population which is under study. Then we have drawn our first sample from population and calculated its sample mean. Then we have drawn our second sample and calculated its sample mean. Then we have drawn our third sample and calculated its sample mean. Now similarly we will continue to draw enough sample and calculate their sample mean. We have data of sample means which was drawn. Then we will express this sample mean distribution in form of probability distribution function, in short PDF graph. Then we did our analysis of sample distribution and found some interesting properties of sample mean distribution. So when these interesting properties are combined, then it is called CLT, that is central limit theorem. Let's discuss these properties. The first property is sample distribution mean is equal to population mean. Second property is sampling distribution standard deviation, or we can say standard error, is equal to the population standard deviation or sample standard deviation divided by square root of n, where n is sample size. And a third property is when sample size is greater than 30, then a sample distribution becomes a normal distribution. We can conclude that whatever is the shape of population, but after doing the sampling distribution, the shape of the sample means distribution becomes almost normal. So the whole point of studying the sampling distribution and CLT is that whenever we want to estimate the population mean, irrespective of whether the population distribution is normal or not, we can use CLT theorem to determine the population mean using the sample mean having some standard error. So this finishes our session on sampling distribution and the central limit theorem. I hope you have enjoyed it a lot. Thank you and happy learning. Hello friends, welcome again. In our last session, we understood the basic concept of sampling distribution and CLT theorem. And in this session, we will learn about application of these concepts. We now know that by CLT theorem, we can estimate population mean from sample mean and sample standard deviation. Let's take an example to understand it more properly. Here the question states that take a sample of 100 employees to find average time taken to reach office in a company of 10,000 employees and estimate the company average time. After doing the analysis, we found the sample mean to be 30 minutes and the sample standard deviation is 10 minutes. Now we will apply the CLT properties to estimate population mean. The first property of CLT is sampling distribution mean, which is equal to the population mean, which is unknown here. The second property is standard error, which is equal to the population standard deviation divided by square root of sample size. Since we do not know population standard deviation, we will go for the sample standard deviation divided by square root of sample size. So here the sample size is 100 and the sample standard deviation is 10. Therefore, the standard error is equal to 10 divided by square root of 100, which is 1 minute. And the third property is, if n is greater than 30, that is sample size is greater than 30, then the sampling distribution will be normal. Since sample size is 100, therefore the sampling distribution is normal. Now we can make claim that the probability of population mean lying between 28, that is 30 minus 2 minutes, and 32, that is 30 plus 2 minutes, is 95%. Now you will be confused how I come to this conclusion about population mean. Just wait for 2 more minutes, everything will be unfolded logically here. In above statement which is made, there are some terminologies related to it. The first one is confidence level, the probability associated with the claim. In the last question, it was 95%, which is confidence level. The second one is margin of error, which is the maximum error made in the sample mean. So in last question, 2 minutes is margin of error. And the third one is confidence interval, which is the interval of values, or we can say range in which the population mean will lie for given confidence level. In the last question, 28 to 32 is the confidence interval for population mean with 95% confidence level. Now we will generalize the confidence interval into a formula, and it is x bar, that is sample mean, plus or minus z into s, which is a sample standard deviation, divided by square root of n, which is sample size. And here z is associated with the confidence level, that is 2 in the last question for 95% confidence level. And now putting the values of last question in the given formula, and the sample mean was 30 minutes, sample standard deviation was 1 minute. So after putting all these values, the confidence interval is coming out to be 28 to 32 minutes, or we can say 30 plus minus 2 minutes, where 2 is margin of error. Now I think all the concept must be coming together and start making sense to you. So this finishes our session on mean estimation using CLT, and I hope you have enjoyed it a lot. Thank you and happy learning. Hello friends, welcome again. In this session we will summarize what we have learned in inferential statistics. The first topic which we have understood is inferential statistics, and it is the process of inferring insights from sample data. Then we have learned about random variable, which is a numerical description of the output of an experiment. Then about probability distribution for random variable, which is how the probabilities are distributed over all possible values of x. Then about binomial distribution, which is the discrete probability distribution. And then about cumulative probability of random variable x, which is random variable x taking value less than small x. Afterwards about the PDF and CDF, which are the preferred for the continuous random variable, as they talk about probability in terms of interval. Then normal distribution, which is continuous random variable is symmetrically distributed and its mean, median and mode lie at the center. And the last one is sampling distribution and CLT. Sampling distribution is the distribution of sample means of population. Then CLT, and it has 3 properties. The first one is sampling distribution mean is equal to population mean. The second one is standard error is equal to population standard deviation divided by square root of sample size. The third one is when sample size is greater than 30, the sampling distribution becomes normal distribution. Then we learn about confidence level, which is probability associated with the claim. Then about margin of error, which is maximum error made in the sample mean. Then about the confidence interval, which is just an interval of values, or we can say it's just a range. So this finishes our session on complete summary on inferential statistics. I hope you have enjoyed it a lot. Thank you and happy learning. Hello friends, welcome again. In this session we will talk about hypothesis testing. So what is hypothesis? So let's understand it with a diagram. We have interest in the population data, so to study it we have drawn sample from the population and perform analysis on the sample data. like descriptive, inferential, exploratory in nature. After analysis, we got some information from which we can make claims about the entire population. But these are just claims. We can't be sure that they are true. So this kind of claims or assumption is called hypothesis. Now let's understand what is hypothesis testing. Suppose we did our analysis on sample data and drawn some conclusion about population on the basis of information obtained. Now we need to test this claim or hypothesis because we are not sure whether they are correct or not. So these claims are tested, and these are tested to determine whether we have enough evidence to conclude if hypothesis or claim made on population parameter is true or false. So this whole process of testing the hypothesis is called hypothesis testing. Now let's understand types of hypothesis in hypothesis testing formulation. The first one is null hypothesis and the second one is alternate hypothesis. Now null hypothesis. It is a status quo. That means there is a prevailing belief about population, that is no change or difference in the situation. Alternate hypothesis, which challenges the status quo, that means it is just opposite to the null hypothesis. So let's understand null hypothesis and alternate hypothesis with the example. Amazon promises to deliver any item within 2 days under Prime membership. So what is the null and alternate hypothesis in this case? So the null hypothesis is item delivered within 2 days. As you know, it is the status quo. Alternate hypothesis, which is opposite of null hypothesis, is item is not delivered within 2 days. So this finishes our session. I hope you have enjoyed it a lot. Thank you and happy learning. Hello friends, welcome again. In this session, we will cover hypothesis formulation. So when we have problem statement which have words like greater than, less than, at least or at most, then we can't formulate the null hypothesis just from the claim statement. Now let's see how we can formulate it. It can be formulated mathematically by following certain rules. The first one for null hypothesis is the claim statement has equal sign or less than and equal sign or greater than and equal to sign. Now for alternate hypothesis, it has not equal sign or less than sign or greater than sign. Let's take an example to understand it. A startup claim its market valuation is greater than $2 billion. Since the claim have greater than sign, that means it is alternate hypothesis. So let's formulate hypothesis. So alternate hypothesis is market valuation is greater than $2 billion and null hypothesis is market valuation is less than and equal to $2 billion. Let's take another example. A startup claim its market valuation is at least $2 billion. Since claim have at least, that is greater than and equal to sign, so it is a null hypothesis. So let's formulate the hypothesis. So here null hypothesis is market valuation is greater than and equal to $2 billion and alternate hypothesis is market valuation is less than $2 billion. So this finishes our session on hypothesis formulation. I hope you have enjoyed it. Thank you and happy learning. Hello friends, welcome again. In this session we will cover making decision on the basis of critical value method. So once you have formulated the null and alternate hypothesis, the next most important step of hypothesis testing is making the decision to either reject or fail to reject the null hypothesis. Before that, let's understand alpha level concept and its significance. Alpha level. In a very simple words, we can say it is the probability of making a wrong decision. Now its significance. It is a region in normal distribution where a null hypothesis is rejected if any test statistics value fall under that region, and usually 5% of the normal distribution is taken as alpha level or it's up to the individual. Graphically you can see that on the left hand side of mu there is a 2.5% of rejection region, on the right hand side also there is a 2.5% of rejection region, and in between is the acceptance region of null hypothesis. Also, the random variable x is a critical value for rejection region where it ends in the left hand side, and we call it lower critical value, in short LCV. Similarly, for right hand side, the random variable x is upper critical value. Now we can generalize the decision rule for rejecting or fail to reject null hypothesis. The first one is, if x, which is test statistics, is greater than UCV or x is less than LCV, then reject null hypothesis, since x lies in a rejection region. The second one is, if x is less than equal to UCV and x is greater than equal to LCV, then we fail to reject the null hypothesis, since x lies in the acceptance region. In normal distribution, we have seen that rejection region was present in both sides of mean. It can be on the left hand side and right hand side also alone. So let's see how we decide where critical region will lie. The type of test and the position of critical region is determined on the basis of sign in the alternate hypothesis. The first one is when alternate hypothesis has not equal to sign. A graph which is shown here falls under this category, and it is called two-tier test, and we know that rejection region is on both sides. The second one is when sign is less than, so test is lower tail test and rejection region is on left hand side. The third one is when sign is greater than, so the test is upper tail test and rejection region is on the right side. Now let's solve a question to understand critical value method properly. The question states that athlete claims that he can complete 100-meter race within 11 seconds. On an average, athlete have completed race in 11.05 seconds and have standard deviation of 0.15 seconds with the sample size of 36. Take alpha equal to 0.05. Here the mean is 11 seconds, that is the claim time by the athlete, and sample size is 36, which is greater than 30, that means sampling distribution is normal, and the standard error, which is equal to population standard deviation divided by square root of sample size. By putting values in the formula, the standard error is 0.025. Now let's formulate the hypothesis. Here the null hypothesis is time taken to complete race less than or equal to 11 seconds, since the claim made by the athlete of completing the race within 11 seconds. Now alternate hypothesis, which is opposite of null hypothesis, will be time taken is greater than 11 seconds. Since there is greater than sign on alternate hypothesis, therefore it is upper tail test with rejection region in right hand side. This is a graphical representation of data which is given to us with the rejection region in right hand side having 5% of normal distribution. Now let's calculate the upper critical value. Using the standardized normal distribution formula of G score, which is equal to upper critical value minus mean divided by the standard error, that rearranging the equation, the UCV is equal to the mean plus G score into standard error, and here we know the value of mean and standard error. Now we need to find the G score for 95% probability by using the table. Since the probability is 95%, which will put G score on right hand side of mu, it means G score is positive. So we will use positive G table to see the G score. So this is the table, and 0.95 lie here, and so row indicates 1.6 and column indicates 0.045. Combining both, we get 1.645 as G score. Now putting G score value into UCV equation, we will get UCV equal to 11.0411 second. Now you can see the claim time 11.05 second on the graph, which lie on rejection region. Since UCV is greater than the claim time, therefore we reject the null hypothesis. So this finishes our session on making decision using the critical value method. I hope you have enjoyed it a lot. Thank you and happy learning. Hello friends, welcome again. The topic which we will cover here is making decision on the basis of p-value method. What is p-value? It is the probability of accepting a null hypothesis or more aptly fail to reject the null hypothesis. Also, we can say that it measures the strength of evidence in support of a null hypothesis. Now let's understand p-value concept graphically. From the normal distribution graph, it is clear that more observation value lie around the mean and very less observation value lie at the extreme end of a curve on both sides. Now there is an observed value, or we can say calculated test statistics, at the extreme end of the curve. So the area under the curve on the right hand side of the observed value is p-value. Here a p-value indicates that observed value or test statistics are as extreme as possible till null hypothesis is true. Also simply we can understand it in this way. If observed value or test statistics are at extreme end, that means p-value is less, which is a reason of very less observation. Therefore there is very less probability of accepting null hypothesis or fail to reject null hypothesis. Now suppose observed value or test statistics is near to the mean. So it means it is a region of more observation value, which indicates p-value is large. Therefore there is a high probability of accepting null hypothesis or more aptly fail to reject null hypothesis. Now we can conclude that higher p-value means high probability of accepting null hypothesis or fail to reject it, and low p-value means low probability of accepting null hypothesis or fail to reject null hypothesis. Now let's see p-value and alpha value. As you know that p-value is a probability of accepting or fail to reject null hypothesis, and alpha value is a probability of rejecting null hypothesis. Let's see the alpha value and p-value graphically. This red region is alpha value, where null hypothesis is rejected if test statistics fall under this region, and which is given by a researcher. And blue one is calculated p-value, which is the area under the curve or probability of test statistics on the right hand side. Now let's see the decision rule on the basis of calculated p-value and the given alpha value. If p-value is greater than alpha value, then we fail to reject null hypothesis. If p-value is less than alpha value, then we reject null hypothesis. Now let's solve a question to understand p-value concept much better. Athlete claims that he can complete 100-meter race within 11 seconds. On an average, athlete have completed race in 11.05 seconds and have standard deviation of 0.15 seconds with sample size of 36. Take alpha equal to 0.05. So given information is, the first one is sampling distribution mean, which is equal to the hypothesized mean, that is 11 seconds, and sample mean is 11.05 seconds, and sample size is 36. Then standard error is population standard deviation divided by square root of sample size. So 0.15 divided by square root of 36 is equal to 0.025 seconds. Now let's formulate hypothesis. Null hypothesis is the time taken to complete race within 11 seconds, and alternate hypothesis is time is greater than 11 seconds. Since alternate hypothesis has greater than sign, so it is upper tail test with rejection region in right hand side. So this is the graphical representation of data which is given to us with rejection region in right hand side having 5% of normal distribution. Now let's calculate the p-value. To calculate it, we will use standardized normal variable formula, that is sample mean minus hypothesized mean divided by standard error, and here sample mean is 11.05 seconds and mean is 11 seconds, standard error is 0.025 seconds, and after putting values in the equation we got g equal to 2. Now we will see the probability in G table when G is equal to 2. Now seeing the row where G equal to 2. Now seeing the column where G is equal to 0.0. So this is the probability at the intersection of row and column, which is 97.75%. So the p-value is 1 minus 0.09775, that is 0.023. So in this graph you can see the region of p-value, and since p-value is 0.023 less than alpha value, which is 0.05, therefore we reject the null hypothesis. So this finishes our session on p-value. I hope you have enjoyed it a lot. Thank you and happy learning. Hello friends, welcome again. In this session we will cover types of error in hypothesis testing. There are two types of error in hypothesis testing. The first one is type 1 error, that is false positive. In this we reject null hypothesis when it is true and it is denoted by alpha. The second one is type 2 error, that is false negative. In this we fail to reject null hypothesis when it is false and it is denoted by beta. Now let's summarize it in a table format. In second column, when null hypothesis is true, we reject it, then it is a type 1 error. And when null hypothesis is true and we fail to reject it, then it is a correct decision. In third column, when null hypothesis is false and we reject it, then it is a correct decision. And when null hypothesis is false and we fail to reject it, then it is a type 2 error. To understand it better, let's take a classic courtroom scenario. A person is considered innocent till he or she is proven guilty. Since it is a status quo, therefore it is a null hypothesis. So, what could be the type 1 error and type 2 error? Convicting an innocent person is type 1 error, as null hypothesis is person is innocent. So, when judge convict the person, the judge has committed a type 1 error, and letting a guilty person to go is type 2 error. So, this can be expressed in the form of table. So, in second column, when person is innocent and declared guilty, that means it is type 1 error. Now, when person is innocent and declared not guilty, that means it is a correct decision. Similarly, in third column, when person is guilty and declared guilty, it is a correct decision. When person is guilty and declared not guilty, then it's a type 2 error. So, this finishes our session on type of error. I hope you have enjoyed it a lot. Thank you and happy learning. Hello friends, welcome again. The topic which we will cover here is t-distribution. So what is t-distribution? It is similar to the normal distribution as it is symmetrical about its central tendency. So how it is different from normal distribution? It is much more shorter and flatter than the normal distribution curve. Here flatter means having a large standard deviation. It is a graphical representation of t-distribution and normal distribution. As you can see that t-distribution is more flatter and shorter than normal distribution. Now some important points about the t-distribution. The first one is, for each t-distribution is associated with degree of freedom, and the formula for calculating degree of freedom is n-1, where n is sample size. The second one is, smaller sample size means more flatter t-distribution. Third one is, when n is greater than 30, then a t-distribution becomes approximately equal to the normal distribution. Now the question arises, when we have to use a t-distribution. So when the sample size is greater than 30 and the population standard deviation is known, then we have to use normal distribution. When both of these conditions are not true, then we have to use the t-distribution. So this finishes our session on t-distribution. I hope you have enjoyed it. Thank you and happy learning. Hello friends, welcome again. In this session we will cover two sample mean tests for paired observation. So when we call two sample mean tests to be paired, when the sample observations are from the same individual or object. Its example is new drug test on the same person to compare before and after impact on person health. Let's take an example to understand it. Here the question states that an ABC company have developed a medicine to normalize the blood pressure, that in short BP of patient, So each patient BP was measured before giving medicine and after giving medicine. Data collected is given below. Please check the effectiveness of the medicine. Take alpha equal to 0.05. This is the data collected and we will solve this question using Excel. Before that, let's formulate the hypothesis. So the null hypothesis is there is no effect of medicine, that is mu2, which is average of blood pressure recorded before taking medicine, minus mu1, which is the average of blood pressure recorded after taking medicine, is equal to 0. And alternate hypothesis is there is effect of medicine, that is mu2 minus mu1 is less than 0. Since alternate hypothesis has less than sign, therefore it is a lower tail test with rejection region on left hand side. Now let's go to the Excel sheet. This is the same table which was shown in the slide. Now let's go and do the two sample mean test pairwise. For that, first of all click data, then go to the right hand side, then click data analysis, then move downwards and you will see t-test pair to sample for means. Then click OK. Now the variable 1 range. This is the variable 1 range. Selecting all of them. And the variable 2 range is this one. And hypothesis mean difference, as we know, is 0. Labels is there. Alpha is 0.05. And output, let's take it here only. Then click OK. So this is the way we will get the output. Let's analyze this result in slides. Now this is the output which we have got in the Excel sheet. Since that it is one tail test, so we will see only the p-value of one tail, and here the p-value is 1.71 e raised to power minus 7. It is very low value as compared to alpha value, which is 0.05. So we can say that since the p-value is less than alpha value, therefore we reject the null hypothesis. Therefore there is effect of medicine on the patient. This ends our session on two sample mean test paired. I hope you have enjoyed it a lot. Thank you and happy learning. Hello friends, welcome again. The topic which we will cover here is two sample mean test for unpaired observation. So when we do two sample mean test unpaired, when the sample observation are independent, for example testing a new drug and comparing effectiveness with the standard drug. Let's understand it with example. An ABC company have developed a drug to normalize the blood pressure, in short BP, of patient. So to check its effectiveness as compared to a standard drug, a group of randomly selected patients was given new drug and another group was given standard drug. And data collected is given below. Please check the effectiveness of drugs. Take alpha equal to 0.05. This is the data collected and we will solve this question in Excel sheet. Before that, let's formulate the hypothesis. Null hypothesis is there is no difference in effect of drugs, that is mu1 is equal to mu2. And alternate hypothesis is there is significant effect of drugs, that is mu1 is not equal to mu2. Since alternate hypothesis has not equal to sign, therefore it is two tail test with rejection region on both sides. Now let's go to the Excel sheet. This is the same table which we saw in the slide. The group 1 represents the standard drugs and group 2 represents the new drugs. Now let's start. First of all, go to the data, click it, then go to the data analysis, click it, then go downwards. You will see t-test for two sample assuming equal variance and two sample assuming unequal variance. Since we do not know the variance of both the variables, so we will do the two sample test assuming unequal variance. Click OK. Then select the first range, this one, and then select the second one, this one, and hypothesis mean difference is 0 and the label is checked and alpha is 0.05. Output, let's take output here only, click, then click OK. This is the output which we have got. Let's now analyze it in the slide. Since it is a two-tail test, we will see the p-value for two-tail. Here the p-value for two-tail is 0.688 and this value of p is greater than alpha value, which is 0.05. Therefore, we can say that we failed to reject the null hypothesis. So, as a result of which there is no significant difference in the effect of the drugs. So, this ends our session on two sample mean test for unpaired observation. I hope you have enjoyed this session. Thank you and happy learning. Hello friends, welcome again. In this session, we will cover two sample proportion tests. So, when we use two sample proportion tests, when the sample observations are categorical, for example, yes or no, true and false, success and failure. Again, we can take the example of comparing the effectiveness of drugs where outcome is defined as success failure, then compare the standard drugs whose outcome is also defined as a success and failure. Now let's take example. Here the question states that an ABC company have developed a drug to normalize the blood pressure of patients. So to check its effectiveness as compared to standard drug, a group of randomly selected patients was given new drug. Then results are noted as success or failure. And another group was given standard drug, then repeating the same process. The data collected is shown below. Please check the effectiveness of the drugs. Take alpha equal to 0.05. This is the data collected is shown. Here 1 represents the success in trial and 0 represents the failure in trial. And we will solve this question in Excel stat as Excel do not have the proportion test in it. And you can easily download it by going to its website. Before that, let's formulate the hypothesis. Null hypothesis is there is no difference in effect of drugs, that is P1 is proportion of success ratio for standard drugs equal to the P2 is proportion of success ratio for new drug. An alternate hypothesis is there is significant effect of drugs, that is P1 is not equal to P2. Now let's see how to download the Excel stat. Go to the Google, then type Excel stat, download and open it. So if you bought Excel stat just for practice, you can take 14 days free trial. Otherwise you need to pay for the full version. Just here fill out your basic information. If you have Windows, then click here and automatically it will download. Now let's go to the Excel stat directly. This is the same table which was shown just now. First of all, we will calculate the proportion of group 1 and proportion of group 2. The total number of success is summation is 3 and total number of sample size is 10. Similarly for the group 2, let's take the summation of success, all the successes, it is 5 and sample size 10. So the proportion is 3 divided by 10 is 0.3 and for the group 2 is 5 divided by 10, it is 0.5. First go to the Excel stat, click here, then go to the parametric test, click here, then go to the test for two proportions, click here. Okay. Here you will be asked for data format, whether it is frequency or proportion. We are here entering the proportions. The first proportion is 0.3. The second sample size is 10, and the second proportion is 0.5 and sample size is 10. So let's see the options. Here alternate hypothesis is P1 minus P2 is not equal to the 0. Significance is 5%, and we are taking variance. Since variance, we do not know the variance of two variables are equal or not. So considering they are not equal, we will select this one and then click OK. We will get the output in this format. And what we need to see, we need to see the p-value. It is a two-tailed test. Now let's go back to the slide to do the further analysis. Now the test results are here and you can see the p-value. It is 0.641, which is quite greater than alpha value, which is 0.05. Therefore we can say that we failed to reject the null hypothesis. Therefore we can also say that there is no difference in the effect of drugs, that is p2 is equal to p1. So this ends our session on two sample proportion test. I hope you have enjoyed it a lot. Thank you and happy learning. Hello friends, welcome again. Now we will summarize what we have learned till now under hypothesis testing. The first one is hypothesis. It is a claim about entire population and not sure if they are true or not. Then hypothesis formulation has two hypotheses. The first one is null hypothesis, which is a status quo and it has equal to or less than equal to or greater than equal to sign. The other one is alternate hypothesis, which is claim opposite of null hypothesis and it has not equal to or greater than or less than sign. For decision making we learn about p-value and alpha value. So p-value is the probability of accepting the null hypothesis or aptly fail to reject the null hypothesis, and alpha value is the probability of rejecting the null hypothesis. Now decision rule: if p-value is greater than alpha value, then we fail to reject null hypothesis. If p-value is less than alpha value, then we reject the null hypothesis. Afterwards we learn about type of error. Type 1 error is false positive, which rejects null hypothesis when it is true and it is denoted by alpha. Type 2 error is false negative, which is failed to reject null hypothesis when it is false and it is denoted by beta. Then about the t-distribution, which is similar to normal distribution as it is symmetrical about central tendency and it is shorter and flatter curve as compared to normal distribution. Then two sample mean test paired. In this sample observation are from the same individual or object. Then two sample mean test unpaired. In this sample observations are independent. Then two sample proportion tests. In this sample observations are categorical. For example, yes or no, true and false, male, female. So this ends our session on summary. I hope you have enjoyed it a lot. Thank you and happy learning.